Greeting to all the viewers. The session is going to cover with the intermediate chemistry. We'll be fetching for your international entrance and the competitive exams as well. India is conducting JEE Advanced and JEE Mains examination to get the admission into the IIT and NIT stream all across India. And NEET exam will be conducted to get the admission into the medical stream. Telangana and Andhra Pradesh government are conducting MCET examination to get the admission into the BTech stream. In addition, if you are aspiring for any government organized job opportunities where general studies common content will be there, general science will be the topic is available in that session. The topic what we are discussing now is very much helpful for that kind of preparation. Let's enter into our today's session. Here, the topic one, or question one, deals with the Nobel Prize in the field of chemistry. The Royal Swedish Academy of the Sciences has decided to award the 1995 Nobel Prize in the chemistry to these three scientists together: Professor Paul Crutzen, Max Planck Institute for the Chemistry, Mainz, Germany, Dutch citizen he belongs to; Professor Mario Molina, Department of Earth, Atmospheric and Planetary Sciences, and the Department of Chemistry, MIT Cambridge, United States of America; Professor F. Sherwood Rowland, Department of Chemistry, University of California, Irvine, United States of America, for their work in the atmosphere chemistry, particularly concerning the formation and decomposition of ozone. Right. So the scientists worked upon how the formation of ozone is possible and in what way it will be depleted, decomposition is possible. That entire study got done by these three scientists together, so that they were accorded with the prestigious world recognition called Nobel Prize in the year 1995 in the field of chemistry. Let's go with that, how the formation and what research they did actually. The ozone layer, the Achilles heel of the biosphere. Atmosphere surrounding the Earth contains small quantities of ozone, right? So already we are aware about the troposphere, stratosphere, ionosphere, thermosphere, exosphere. So all these are the part of our atmosphere. In that, a small quantity of ozone is available in the stratosphere, a gas with the molecule consisting three oxygen atom. O3 is the allotrope of the oxygen. If all the ozone in the atmosphere were compressed to pressure corresponding to the Earth's surface, the layer would be only 3 mm thickness. Extremely minute quantity we can understand, and it is even we are taking all the ozone at particular region by compressing, by applying the pressure, so that the thickness is only of 3 mm thickness. That extent of a tiniest layer it will be. But even though ozone occurs in this much smaller quantities, it plays an exceptionally fundamental part in the life on the earth. This is because ozone, together with the ordinary molecules of the oxygen, is able to absorb major part of the sun's ultraviolet radiation, and therefore prevent this dangerous radiation from reaching the surface. Without a protective ozone layer in the atmosphere, animals and plants could not exist, at least upon land. It is therefore of the greatest importance to understand the processes that regulate the atmosphere's ozone content. Whatever ozone layer in that atmosphere, though it is of very thinnest wall, thinnest layer upon the surface of the earth, but it gives the exceptional protective power. So very harmful rays are coming from the radiation, so that so whatever light optimum to the human and all the living organisms can be transmitted, remaining harmful lights, harmful radiation got absorbed by this umbrella of ozone layer, whichever present, whichever protecting the entire surface of the earth, so that the harmful radiation, direct radiation, got minimized by means of this ozone layer, which used to protect the entire, it used to shield the entire surface of the earth. Paul Crutzen, Mario Molina, and Sherwood Rowland have all made pioneering contributions to explaining how ozone is formed and decomposing in the atmosphere. Most importantly, they have in this way showed how sensitive ozone layer to the influence of anthropogenic emissions of the certain compounds. The thin ozone layer has proved to be a Achilles heel that may be seriously injured by the apparently moderate changes in the composition of the atmosphere, right? Ozone layer is available, and these three scientists got studied what is the composition actually, how it is forming in the environment, and in what way it is showing its protective activity. This entire study got done by these three scientists together, right? Most importantly, how sensitive ozone layer for the influence of anthropogenic activities. Anthropogenic activities are nothing but, anthropogenic emissions are nothing but man-made activities are going to emit some kind of chlorofluorocarbons will be there, and oxides of nitrogen and sulfur will be there. Especially chlorofluorocarbons are the main cause for the depletion of the ozone layer. So that kind of emissions are regarded as anthropogenic emissions, we can say. And ozone layer has proved to be an Achilles heel that may be seriously injured by the apparently moderate changes composition in the atmosphere. Because of some changes and alternatives in the environment, so that kind of serious injury got happened for this ozone layer. By explaining the chemical mechanism that affect the thickness of ozone layer, three researchers have contributed to our salvation from a global environmental problem that could have catastrophic consequences. Okay, so even if we are not taking care about that one, what happens, that injury get increased, so that give the worse impact on the entire lifespan of the earth. That's the reason why the scientists together worked upon what in what way this kind of damage to the environment or ozone layer was done, and what are the causes for this one, and what consequences we will face if this is continued for further. So that kind of entire research, valuable research we can say, because it is the kind of livelihood, standards of livelihood to for or the entire mankind whoever surviving on the earth, so that they contributed for the salvation in the global environmental problem and could have the catastrophic consequences, right? So this is the way the scientists Paul Crutzen, Mario Molina, and Sherwood Rowland together worked upon this ozone, how the ozone layer composition was made, and in what way it is protecting, and what kind of applications we can notice, how it is going to be damaged, or else what kind of damage we already had, and what to be the steps to taken for the restoration, and that how to avoid the depletion of the ozone layer. That entire study was done by these three scientists together, which is the most important contribution for the environmental protection, right? How this knowledge evolved. Ozone is formed in the atmosphere through the splitting of ordinary oxygen molecules. Oxygen molecules are present. Oxygen is the part of atmosphere. Around 21% contribution is given by this oxygen. Whenever these oxygen molecules are in the direct contact with the ultraviolet radiation emitted from the sun, so that oxygen will be dissociated and giving rise to the nascent oxygen. Here, oxygen atomic one is said to be a nascent oxygen. The nascent oxygen can combine with the molecular oxygen. M denotes what? Random air molecule. M for air molecules will be there. Entire process carried in the atmosphere, so that air is also the part of this reaction, right? Nascent oxygen combines with the molecular oxygen, so that ozone molecule will be generated, and random air is emitted as the product. This is the way ozone molecule will be generated in the nature, by nature only, right? So the English physicist Sidney Chapman formulated in 1930 first photochemical theory for the formation and decomposition of ozone in the atmosphere. How this formation of ozone is possible in the atmosphere was done by the eminent English physicist Sidney Chapman in the year 1930. So its composition and followed by, being it is a kind of very short-lived, that means very reactive in nature, so that immediately back converted into oxygen, right? That's the reason why formation and decomposition are vice versa reactions. That entire study was carried by the Sidney Chapman and in the atmosphere, and it described how sunlight convert the various forms of oxygen into one another, and explains why the highest content of ozone occurs in the layer 15 to 50 kilometers. This 15 to 50 kilometer region is the part of stratosphere. So the starting layer of the earth is regarded as a troposphere, and the next level is called stratosphere. In that 15 to 50 kilometers region, this ozone will be appeared, and that is termed as a ozone layer, right? So if you observe in this graphical representation, variation in the temperature and ozone concentration up through the atmosphere. So here temperature will be there, and the region which is just near to the earth surface here, you can notice up to 10 kilometers, it is regarded as a troposphere. As we are moving up, so up to 50 kilometer region, you can notice 10 to 50 kilometer in between, the entire region is the part of stratosphere, where the jet planes and all the kind of aviation devices are moving. And this 50 to 80 kilometers region, mesosphere will be there, and above that you can notice the exosphere and near to that sun. And here ozone concentration, how it will be varied. So at the bottom troposphere, we are experiencing ozone concentration somewhat less. Ozone is not that extent, but if you observe in between the 10 to 50 kilometer region, ozone is appeared in the maximum quantity. If you observe, this is the part, this is a region, you can notice stratosphere is experiencing maximum concentration of this ozone, because it is only the region where the probable decomposition of oxygen giving rise to the ozone is possible, right? Later on, as we are moving up, temperatures are still increasing, so that at the temperature ozone may not exist. That's the reason why here you can notice the ozone concentration is going to the down levels. So this is the way curvature indicating ozone concentration, which is maximum at the region of stratosphere laying in between 10 to 50 kilometers of zone, right? The calculated ozone content were considerably higher than the observed one. So this is the graphical representation. This is the hypothesis assumption we made. But in practice, whatever concentration we are expecting, the existing practical concentrations are much higher. Higher concentration of ozone is there in the environment. There must be other chemical reactions contributing to the reduction of ozone content. So ozone, being it is highly reactive, can react so that it will be transformed into any other components as well. Some years later, Belgian Marcel Nicolet contributed important knowledge of how the decomposition of ozone was enhanced by presence of hydrogen radicals, OH minus, and water. Right. So ozone decomposition is increasingly done because of the presence of free radicals in the environment. Those are accelerating that. What happens here, as already we noticed, oxygen can be easily converted into ozone in the presence of ultraviolet radiation. Again, ozone will be transmitted back into the oxygen molecule. But in the presence of free radical, one-way reaction is facilitated, rather suppressing backward reaction of oxygen formation, ozone formation. So this is the way radicals are making a decrease in the concentration of this ozone, right? The scientists to take the next fundamental step towards a deeper understanding of the chemistry of the ozone layer was Paul Crutzen. In the year 1970, he showed that nitrogen oxides, nitric oxide and nitrogen dioxide, react catalytically without themselves being consumed with ozone, thus accelerating the rate of reduction of ozone content. So these are another contributor for the ozone depletion. One is said to be nitric oxide, another is called nitrogen dioxide. Whenever they are in nitric oxide is in direct contact with ozone, they will consume the ozone, and nitric oxide turned into nitrogen dioxide, so that molecular oxygen. Ozone converted into molecular oxygen, so that ozone concentration obviously decreased. So this is called depletion. Whenever nitrogen dioxide reacted with the nascent oxygen, what will be happened? Nascent oxygen will be combined with the nitrogen, so that nitric oxide will be formed. Again, molecular oxygen will be formed. Even ozone, upon reaction with this ultraviolet radiation, oxygen and nascent oxygen will be possible. Ultimately, ozone is slowly converted into molecular oxygen, so that concentration of ozone is slowly decreasing. So whenever concentration of ozone is decreasing, that is called depletion of the ozone layer. Ozone concentration decreases, there is a certain holes generated over stratosphere. These nitrogen oxides are formed in the atmosphere through the decay of chemically stable nitrous oxide, which originated from the microbiological transformation at the ground. The connection demonstrated by Kurtzman between the microorganisms, soil, and thickness of the ozone layer, one of the motive for recent rapid development of research in the global biochemical cycles. Right. So here, this formation of nitric oxide, nitrogen dioxide is possible by taking nitrous oxide as the starting material. This entire depletion and what decomposition of ozone was studied by Kurtzman, and this is the nitrous oxide, which is liberated from the microorganisms which are present in the soil and the ozone layer. A depletion is possible because of the presence of this nitrous oxide, right? There is a certain kind of biochemical process got carried over. This is the way the study got carried. A detailed study got carried by Paul Kurtzman and Mario Malina. Sherwood Rowland, these three scientists together worked upon the international environmental problem, so that outstanding work was accorded with the Nobel Prize in the year 1995 in the field of chemistry. By this, we can conclude question 1. Let's move on with the question number 2, Cambridge Assessment International Education. The question was collected from. The question is about group 4 elements and their compounds. The changes of the state of the lead are shown over. Solid lead was taken, and upon melting, it will be turned into a liquid lead. Liquid lead will be further, this is called thermal change is possible, giving rise to the lead gas. So this is a kind of phase transition. Solid to liquid, liquid to gaseous phase transitions are possible. Whenever melting is possible, solid turned into a liquid. Liquid obviously converted into a gas by boiling process, right? Then gaseous components get aggregated. That aggregation process is called condensation. So whenever gas is condensed, so that liquid will be appeared. The liquid further frozen, that is called a freezing point. So that upon freezing of liquid, you can achieve the solid lead. This is the way all physical transitions. We are not supposed to change the chemical composition. In all the possible ways, you are getting lead only. But only the thing is, kind of its a physical state got varied, right? This is the way physical transformation got carried. Name the changes of the states represented at A and B. Obviously, A will be a freezing one, B will be a boiling one. This is the way we can answer. Use the kinetic particle model to describe the difference between the liquid lead and the lead gas in terms of separation of particles, motion of the particles. In order to get these answers, first of all, this question got answered. Conversion of liquid lead into the solid lead is called a freezing. Liquid lead into the lead gas is called a boiling. So this is the way question 1 is solved. And in case of question 2, kinetic particle model was apted for liquid lead and lead gas. In case of this one, the separation of particles in a liquid. If you observe liquid, all the particles are loosely bounded. They are not in the fixed, definite position. Rather, they are certain extent flexible, and they are in motion. liquids are in motion, right? Separation of particle will be there up to certain extent. But force of attractions are operated in order to avoid the entire separation. That is the way certain forces are operated, but compared to solids, it will be somewhat lesser. And compared to solids, the packing is also somewhat loosely bounded. So not exactly definite structure, three-dimensional structure, rather it will be the random arrangement we can notice. That is about separation of particles in a liquid one. Move on to gaseous particles, all are well separated, freely moving. They are not dependent on one particle upon another, freely moving without affected by the surrounding particles. This is about the free motion of the gaseous particles. Let's go with the motion of the particles. This is about what? Arrangement of the particles. All the particles are well separated in gaseous one, somewhat loosely bounded in the liquid one. But in case of motion, move around each other. Movement will be there. Always liquids are having movability. Mobile substances only called as liquids. So that we can say movability will be there. Movement is possible for the liquids. In case of gases, they are able to move in the faster pace, move very quickly in all possible directions. All possible directions they are able to move. That is the motion of the particles in the gaseous one. This is the way we can answer all the questions which are posed in the question number 2. Let's go with the question number 3, which is collected from JEE Advanced 2015 question paper, paper 1 question conducted by the National Testing Agency. The percentage yield of the ammonia gas as the function of the time in the reaction nitrogen upon treating with 3 moles of hydrogen, giving rise to 2 moles of ammonia. And delta H value is less than 0. That means negative. And the pressure for this reaction is indicated as P, and the temperature is mentioned as T1, which is given below. Time taken on the X coordinate and percentage yield taken on the Y coordinate. At the 0 time reaction percentage yield also 0, because we are not yet started the reaction. At the time 0 yield will be there. As the time proceeds, in accordance, the percentage of yield also increased up to certain extent, but afterwards there is no change in the percentage of yield. Percentage of yield remains the same. So it is not moving upward, rather it is moving in the straight line. Up to certain extent, yield is increased. Later on, yield remains almost similar. That is for temperature T1. Right. So this is the graph represented for the synthesis of ammonia. If this reaction is conducted at a pressure and temperature T2, then obviously T2 temperature is taken greater than T1. What will be the percentage of yield of ammonia as the function of time represented by? So if this is the condition, so same reaction, synthesis of ammonia we are going to do. For the synthesis of ammonia, pressure and temperature T2 was taken, where T2 value is greater than T1. At that condition, what will be the percentage of yield of ammonia in graphical representation? So T1, T2 to be compared. Expected answer is represented over here. Time versus percentage of yield, if we observe, T1 graph already we noticed like this. A curvature we can notice so that we are not supposed to change T1. So in all possible A, B, C, D options, T1 curve remains the same. Sorry, here T1 curve should be same. So if T1 curve changed, this is not correct. We can cancel out blindly. So because the T1 curve already given within the problem, so that we have to follow this one only. So T1 curve already there, but T2 curve we have to depict. In order to get the T2 curve, the T2 curve initially higher than the T1. But after reaching certain point, it is lower in nature. It will be constant. It is not increasing its yield after certain amount of time. This is the exact representation. Let's go with the explanatory part for this one. Why it is happening like that? Initially, as temperature increases, as we are moving with the time, percentage yield also increases in the faster pace. If you observe clearly, so along with the time, the percentage yield also increased up to this extent. But when we reach a particular temperature, when we reach a particular time period, reaction is exothermic. Obviously, within the problem only they mentioned delta H is less than 0 means it is negative, right? Negative is nothing but delta H values are negative. Enthalpy change will be negative whenever heat evolved during the reaction, which is called exothermic reaction. So since the reaction is exothermic, delta H values are negative, right? Whenever delta H values are negative, but they mentioned one more term within the problem only. The temperature T2 is higher in comparison to T1, right? When already reaction is evolving heat and still we are supplying the heat, what happens? Reaction will be suppressed. Already that reaction having natural tendency to release the heat, no. But still we are rising temperature because T2 is greater than T1. That means we are rising temperature. At that condition, reaction will not be facilitated. Rather, it will be suppressed so that T2 temperature level, yield of the product will be minimized in comparison to the T1. So, because being it is the exothermic reaction, low temperatures are preferable for the higher yield. But already exothermic, we are also supplying the heat so that higher temperature will suppress the rate of reaction. So, that's the reason why after reaching particular point, the equilibrium percentage of yield will not be varied. It will be lower in nature. So that is clearly indicated in the option number A. So that option number A is the correct answer for question number 3. So that we concluded with the question number 3 and moved into question number 4. Again, it is collected from 2015 JEE Advanced. 2015 question paper 1 conducted by the National Testing Agency. If the unit cell of the mineral has a cubic close packed CCP array of the oxygen atoms with m fraction of octahedral holes occupied by aluminum ions and n fraction of tetrahedral holes occupied by magnesium ions, m and n respectively are. Okay, this is the question collected from the solid state chemistry, and where you can notice the unit cell of mineral. One of the mineral was taken whose composition is a cubic close packed. In case of cubic close packed system, m fraction of the octahedral holes will be there. N fraction of the tetrahedral holes will be there. M fraction octahedral holes got occupied by aluminum ions and tetrahedral holes occupied by the magnesium ions. In that condition, what are the values of M and N? M and N values to be identified. For that purpose, we have the answer 1 by 2 and 1 by 8. In order to get this, we have to go for the calculation part. How many oxygen atoms are there? Mineral where the array of oxygen atoms with m fraction. So here cubic close packed system if taken into the consideration, contribution of the atoms, CCP is having contribution of the atoms are 4 atoms will be there. If 4 atoms are present over, and in that the number of octahedral holes will be 4 again. So for CCP octahedral holes are 4 and tetrahedral voids will be 8. So let me repeat again. For CCP lattice, number of oxygen atoms are 4 and tetrahedral voids are 4, octahedral voids are 8. At that condition, this octahedral voids got occupied by aluminum, right? So that aluminum can be multiplied with 4 because they are occupied in the octahedral holes. So that 4 multiplied with m fraction of octahedral holes. At the same time, magnesium ions got occupied in a tetrahedral voids, so that 8 is the numeral can be multiplied with n factor. N factor can be taken here. N is the tetrahedral void fraction taken. Molecules of the mineral will be neutral. So neutral mineral was taken. That's why no charge is noticed is equal to 0. We have to put over. Then let's take each oxygen is comprised of -2. Oxygen always carries the -2. How many oxygens we have? Oxygens are 4. So that 4 multiplied with -2 plus. Then how many aluminum atoms got occupied? Number of aluminum ions occupied are 4m. Then each aluminum is contributed with +3 charge, trivalent in nature. So that 4m can be multiplied with +3. Then Number of magnesium ions are 8n, right? 8n. Each magnesium contributed with bivalent charge. +2 charge will be there. So that let me get the sum of 4 multiplied with -2 plus 4m plus 3 plus 8n plus 2 is equal to 0, being it is a neutral one. Okay. At that condition, let me go with the calculation part. 4 multiplied with 3, it is the 12m. 8 multiplied with the 2, that is the 16n. And 4 multiplied with 2 is the 8. So -8, whenever we are taking right hand side, it will become a positive one. Then if we take the entire left and right hand side equation is divided with 4, when the division got carried, 4 3s are 12, 4 4s are 16, 4 2s are 8. So that the minimum equation, empirical equation, we got 3m plus 4n is equal to 2. At that condition, if we go for the calculation, we will get, if we go for the calculation, we will get m is equal to 1 by 2, n is equal to 1 by 8 after the entire calculation. This is the way 1 by 2 and 1 by 8 are the expected answers for the question number 4. This is the way solution for the question 4 we will obtain. Go with the question number 5. It is collected from the Telangana MCET examination conducted in the year 2020. Which among the following is our primary components of the synthetic gas? క్రింది వాటిలో ఏది లేదా ఏవి సంశ్లేషణ వాయువు యొక్క ప్రైమరీ ఘటకము లేదా ఘటకాలుగా ఉన్నాయి? Right. So synthetic gas components, primary components to be identified, carbon monoxide and hydrogen is the correct answer. These are the components of the syngas. Syngas is nothing but synthetic gas, which is also called as a blue gas. Let's see. The content collected from the Wikipedia, here you can notice syngas is nothing but synthetic gas. It is the mixture of hydrogen and the carbon monoxide in the various ratios. The gas often contains some carbon dioxide and methane. It is principally used for producing ammonia or methanol. Whatever syngas are mixture of hydrogen and carbon monoxide we have, this mixture used for the synthesis of ammonia or methanol. Syngas is combustible and can be used as a fuel again. So many applications you can find. The gasoline supply, wood gas used to power the cars in the Europe during this that means it is also taken as a fuel, right? So this syngas can be synthesized by taking methane can be combined with the water and giving rise to the carbon monoxide and hydrogen. The mixture of carbon monoxide and hydrogen is said to be synthetic gas in principle, but rarely in practice. Biomass and related hydrocarbon feedstocks could be used to generate biogas, biochar, waste to energy. Waste to energy is also possible over there. Gasification facilities. The gas generated, mostly methane and carbon dioxide, is sometimes described as a syngas, but its composition differs from the syngas. Generation of conventional syngas, H2 and carbon monoxide waste biomass has been explored. So that whatever waste products are there, from that also syngas synthesis is possible. This is the kind of positive indicator to mitigate the environmental pollution. So that ultimately syngas is the mixture of carbon monoxide and hydrogen. It is the kind of eminent fuel we can say, and that is mentioned in the option number 1. For question 5, option 1 is the right answer. Let's go with the question number 6. Last question of the session. Which of the following is an air pollutant? Air pollutants are the kind of gaseous substances, even solid. Solid substances also present, but a gaseous substance in general are able to give the air pollution. ఈ క్రింది వాటిలో ఏది వాయు కాలుష్యము? Pesticides, phosphates, biphenyls, or else oxides of the sulfur. Among all, which is said to be an air pollutant? Oxides of sulfur is the kind of air pollutant. Biphenyls, phosphate, pesticides, we can't say they are air pollutants. So that sulfur dioxide is the right answer. Let's see how can we say sulfur dioxide is the kind of air pollutant. This is the one collected from Environmental Protection Agency called EPA. United States Environmental Protection Agency. Sulfur dioxide basics. Sulfur dioxide, how does it get into the air? What is sulfur dioxide actually? According to Environmental Protection Act's National Ambient Quality Standards, sulfur dioxide are designed to be protected against exposure to the entire group of sulfur oxides. Sulfur oxides, that means there may be a possibility of sulfur trioxide, sulfur dioxide, sulfur polyoxides also available. So component of the graded concern and is used as an indicator for the larger group of gaseous sulfur oxides. Other gaseous sulfur oxides such as sulfur trioxide found in the atmosphere in the concentration much lower in comparison because sulfur dioxide is the commonly observed gaseous substance. Control measure to reduce sulfur dioxide can generally be expected to reduce the people's exposure to all the gaseous sulfur oxides. This may have an important co-benefit in the reduction and formation of sulfur pollutants such as fine sulfate particles. Emission that lead to the high concentration of sulfur oxide generally also lead to the formation of sulfur oxides. Largest source of sulfur dioxide emission is the fossils, right? How does sulfur dioxide get into the air? The largest source of sulfur dioxide, burning of fossils are possible, small source of sulfur dioxide. Industrial process also used to release the sulfur dioxide gas, and even volcanoes, locomotives, ships, vehicles and heavy equipments, all are the sources of oxides of sulfur. What are the harmful effects we can notice? Health effects will be there. Human respiratory, being sulfur dioxide is a kind of a corrosive one. It used to rupture the sensitive tissue of the skin, so that respiratory disorders are possible. Breathing is becoming difficult, asthma related problem, and sensitive for the sulfur dioxide. This is the way they are causing effects. Environmental effects of sulfur dioxide. High concentration gaseous sulfur dioxide can harm the trees and the plant materials, even can be mixed up with the rain so that acid rains are possible. And visibility, sulfur dioxide or the sulfur oxide can react with components atmosphere to form particles that reduce the visibility, so that haze will be generated in the air, so that it looks like a cloudy one. We are not able to see the route in a clear manner. This is the way sulfur dioxide is said to be a kind of pollutant over there. So by this, we entirely completed the session, and the real informative content was taken from the authentic sources, and I can assure for the informative session was given to you, and so many times repeated questions were collected from the previous year exam question papers. And I'm sincerely requesting you to all to like the channel, and in order to comment, we have a question for the session. The question related with the transformation, whenever you go with the solid to liquid, liquid to gaseous substance of anyone, let me go with simple water only. In case of that one, six kind of what table we can notice. In that condition, you can mention with each and every phase of transition what we can mention and what temperature you can notice. Along with the temperature description, you can mention the entire chart for the conversion of solid water to liquid water to gaseous one, gaseous to liquid, gaseous to solid is possible. Different conditions are possible that to be taken as a question for the session and to be commented in the session only, and share with the aspirants who are more curious about the examination, and subscribe the channel. Definitely we will come up with the new content in the near future. Thank you all for your consistent listening.